Okay, good afternoon students. So today we are going to proceed with exercise 6.3. So in this exercise we will be getting indeterminate forms of the 0 to the power 0, infinity to the power 0, 1 to the power infinity. So far we have covered 0 by 0 form, right? Infinity by infinity form, right? Infinity minus infinity form, okay, and 0 into infinity form. So far we have come up with this type of indeterminate forms, and how to evaluate we have done in the previous exercise, isn't it? But now in this exercise what we'll be doing is we will be coming across this type of indeterminate forms: 0 to the power 0, infinity to the power 0, and 1 to the power infinity. Okay, so suppose if we get a question like this, how we'll be able to do? Let us check now. Okay, the given question out here is limit x tending to alpha, x minus alpha to the power x minus alpha. Okay, so if I put the value for x as alpha out here, alpha minus alpha is 0. And in the power also, if I put x equals to alpha, alpha minus alpha is 0. So therefore I'm getting the form 0 to the power 0 form. Clear? Okay, I'm getting this first form 0 to the power 0. So I have identified, yes, this is a form 0 to the power 0. Now what will I do? Now the first step is, we'll start with the assumption. You have to follow the steps strictly out here. Okay, let us assume capital Fx as the given function, x minus alpha to the power x minus alpha. This is the first step. The second step is that we'll take log both the sides. So taking log, and you will be doing the steps in each and every sums of this exercise. Okay, first assume capital Fx, and then the second step is taking log both sides. So log Fx is equals to log x minus alpha to the power x minus alpha. We'll have to write out the reason, taking log both sides. Okay, so taking log both sides. So now this implies log capital Fx is equals to, the power comes as the coefficient x minus alpha and log of x minus alpha. Okay, the first step is to assume capital Fx. The second step is to take log both the sides. I get this. And the third step now is we'll have to put the limit, the same limit which is given in the question. Okay, so in this case, limit x tending to alpha. So if you write down taking limit x tending to alpha both the sides. So therefore we will be getting, okay, I've used LIM, or you can write LT at the same thing. Okay, limit x tending to alpha log capital Fx is equals to limit x tending to alpha x minus alpha into log x minus alpha. Okay, I hope you people are clear with this step, taking limit both the sides. Now keep your left hand side as it is. Now what we have to do is only in the right hand side, and so far we have come across 0 by 0, infinity by infinity, infinity minus infinity, and now let us see what we are getting. Okay, so if I put x equals to alpha, out here, okay, we are checking the limit. If I put x equals to alpha, this is 0, and if I put x equals to alpha out here, I am getting log 0, isn't it? So log 0 means infinity, so I'm getting 0 into infinity form, and yes, we have done this 0 into infinity form in the previous exercise, isn't it? So therefore now if I get 0 into infinity form, then either I have to make 0 by 0, or either I have to make infinity by infinity. Okay, the easiest thing out here would to make the form as infinity by infinity. So how we'll do that is, keep your left hand side as it is. Log capital Fx is equals to limit x tending to alpha. Okay, I'll write this as log x minus alpha and divided by 1 by x minus alpha. So this much we can do. Okay, because this goes as a reciprocal and it gets multiplied with the numerator, which is log x minus alpha. Now if I check the form, you put x equals to alpha in the numerator, so 0, and log 0 is infinity. You put x equals to alpha out here, 0, so 1 by 0 is infinity. Hence the form out here is infinity by infinity form. Infinity by infinity form. So now we have to use LH rule. So write down by using LH rule, okay, only on the right hand side, by using LH rule on the right hand side. The left hand side remains as it is. Limit x tending to alpha log capital Fx, which is equals to, on the right hand side, say I have to differentiate the numerator, I have to differentiate the denominator, isn't it? So limit x tending to alpha log of x minus alpha, so 1 by x minus alpha, and differentiation of x minus alpha is 1 whole divided by, this is, assume this as x, so this will be x minus alpha to the power minus 1, so hence it will be minus 1 by x minus alpha to the power minus 2, isn't it? So therefore it will be plus 2, bringing it in the denominator, and into differentiation of x minus alpha is always 1. So all in all, I'll be getting this much. Okay, which is same as log x by 1 by x that you have done in the previous sum, isn't it? So therefore, x minus alpha and square gets cancelled out, and this goes up in the numerator. Therefore, I will be getting limit x tending to alpha log capital Fx, which is equals to minus is a constant, limit x tending to alpha. Okay, hence I will be getting only into x minus alpha. So this is the step what I'm getting out here. Let me write this in the next page. Limit. So therefore limit x tending to alpha log capital Fx, which is equals to minus limit x tending to alpha x minus alpha. So I'll be getting this much, isn't it? So now when I put the value for x equals to alpha, I'm not getting any undefined values. I'm simply getting 0. So therefore limit x tending to alpha log capital Fx is equals to minus, this is alpha minus alpha. I'm putting the value for limit. So therefore limit x tending to alpha log capital Fx, and this is alpha minus alpha is 0, so minus 0, so hence it is 0. So now is the very important step. Okay, that step is to interchange the limit and log. We can always interchange the place of limit and log. Log comes out here, limit goes inside. Okay, so therefore log within the bracket limit x tending to alpha capital Fx is equals to, this is 0. Okay, now so therefore you have to write down interchanging limit and log. The same thing you'll be getting in your examples also. If you see the examples, we can always interchange limit and log, so not a problem for us. Now we have to use a property of logarithm. Okay, remember that the base is not given out here. The base of logarithm is always e. So whenever I remove logarithm, if log of this is equals to 0, now this comes from the definition of logarithm. Okay, if log of any number is equals to 0, then that number is e to the power 0, or base to the power right hand side. Okay, once again I'm repeating, if log of any number is equals to 0, then the value for this number is e, the base to the power right hand side. So hence in our case, this number limit x tending to alpha capital Fx will be base is e to the power 0. Okay, from the definition of logarithm, limit x tending to alpha. Now what was the capital Fx? According to our assumption, capital Fx was x minus alpha to the power x minus alpha, isn't it? So therefore x minus alpha to the power x minus alpha, and we know e to the power 0 is always 1. So hence we can always solve this type of problems like this. Okay, it was a very lengthy video just for one sum. I hope you people will understand. I'm pausing for a while. Okay, so let's continue our work. Now the next question I've taken is question number 2 part 1. Okay, let's start with the question. Limit x tending to 0 tan x to the power sine 2x. Okay, limit x tending to 0 tan x to the power sine 2x. Okay, first of all let us check the form. You put x equals to 0, so tan 0 is 0, sine 0 is also 0. So what is the form? 0 to the power 0 form. Okay, the previous one was also which form? 0 to the power 0 form, and this one is also which form? 0 to the power 0 form. Okay, again the same steps we need to follow. Let us start with the assumption. Assumption will be capital Fx as the given function. Assume this as x, Fx, assume this function as capital Fx. The second step is to take log both the sides. So take log both the sides. Log of this is equals to log of this. Property of logarithm tells us that the power comes as the coefficient, which is the third step. The fourth step is very important as well, taking the limit. Whichever limit is given in the question, the same limit you have to take. Okay, taking limit x tend to 0 on both the sides, we get limit of this is equals to limit of this. Now here also, if you check the form, sine 0 is 0, and log of tan 0 is 0, and log 0 is infinity. So what is the form? 0 into infinity form. So I hope you have got the idea now. Okay, I hope you people are getting the idea now. Once I get 0 into infinity form, then it's simple. Either I make in the form of 0 by 0, or either I make it a form of infinity by infinity. Here also I can write this sign as log of tan x as it is, log of tan x as it is, and then sine 2x as 1 by sine 2x. This goes in the denominator. Once it goes in the numerator, it gets multiplied and get the same step again. Okay, so therefore next step, left hand side, same, limit x tending to 0, log of tan x divided by 1 by sine means cosec. And now when you check the form, limit x tending to 0, log tan 0, log of tan 0 is 0, log 0 is infinity, cosec 0. Now sine 0 is 0, so cosec 0 is infinity. I hope you people can identify the form. It is infinity by infinity. So what will I do now? Since it is infinity by infinity form, what will I do now? We'll have to use again L'Hopital's rule, LH rule out here. Okay, so I'll do the differentiation and then I'll explain to you again. Clear? So okay, therefore the next step, once we identify it is infinity by infinity form, then we can use LH rule on the right hand side. So by LH rule on the right hand side, see the left hand side remains as it is, but the right hand side, limit x tending to 0, differentiate log tan x, 1 by tan x into sec square x. Differentiate cosec 2x minus cosec 2x into cot 2x into 2. I hope you people are clear with the differentiation part. Okay, therefore we move to the next step. So 1 by tan means cot, and into sec means 1 by cos square. Okay, and minus I have changed cosec as 1 by sine, cot as cos by sine, and then into 2. Right? The next step, we move to the next step. In the next step, what I have done is cot means cos by sine. And let's see, okay, in the next step. So therefore, this is your next step. Limit x tending to 0, log fx is equals to limit x tending to 0. So remember that was cot. Cot means cos by sine. Cos and square gets cancelled out. And then, even here also, this was 1 into cosec into 2. So 1 into cosec, cos into 2. Okay, so therefore this will be 2 cos 2x divided by sin 2x into sin 2x, which is this step. Okay, so cos 2x divided by sin 2x into sin 2x into 2. It gets cancelled out. So in the next step now, this goes up in the numerator, this goes up in the numerator, and this gets multiplied with this. Okay, so this goes up in the numerator. Therefore this step, sin 2x into sin 2x, and then here I'll be getting sin x into cos x into 2. So then here I'll be getting sin x into cos x into 2. Isn't it? Because this is the denominator. It gets multiplied with 2 and cos 2x. So 2 into sin x into cos x means sin 2x into cos 2x, and this is in the numerator. So when you do the calculation, when you do it properly, you'll come to understand, not to worry. Okay. So minus sign. This minus sign is outside of limit. Here, limit x tending to 0, you will be getting sin 2x into sin 2x divided by sin 2x into cos 2x. And what happens out here is sin 2x and sin 2x gets cancel out. So therefore sin 2x by cos 2x means tan 2x. Now I put the value for limit x tending to 0. So tan 0 is 0. Again, you will be getting a similar type of what we have done in the next previous sum. So limit x tending to 0, log fx. So if you put limit x equals to 0 out here, this is going to be tan 0. And what is tan 0? Tan 0 is 0. So minus tan 2 into 0. So therefore limit x tending to 0 log fx is equals to minus tan 0 is 0. So the next step again, limit x tending to 0 log fx is equals to 0. Now interchange limit and log. This is the final step. Okay, so log and within the bracket limit x tending to 0 fx is equals to 0. The base is e out here, so e to the power 0 is 1. We know that limit x tending to 0 fx is equals to e to the power 0. We lengthy sum. So move to the next page. Limit x tending to 0, capital fx, e to the power 0 is 1. Let us replace the value for fx. The same step again. So limit x tending to 0, fx is out here tan x to the power sine 2x, and which is equals to 1. So hence we complete the answer in this way. Okay. And yes, let's not forget the homework assignment number 3. Today's assignment will be question number 3 part 1, 4 part 1, 6 part 1, and example number 4. Please try to do it. Very important. A chapter we have finished today, and tomorrow let's see which chapter we will be starting. Okay, so that's it for today.